All right, so we are skipping 4-1, though I might assign it and just give you a. We're gonna skip 4-1, though I might assign it and give you a work day. It was basically taking it. It was basically a review. Okay, so yeah.
So does that mean we're only doing 4.2 this week because we have no day on Friday because Friday is gone.
So we get Monday. Today's Monday.
Yeah.
So tomorrow's work day. Wednesday we'll do notes. Thursday. And then
Wait,
why
do we
not
about 4.1?
Why do we
He's
not?
still assignment.
Maybe.
does anybody go back and watch the notes? Because
I do.
okay, good.
I do a lot.
All right. Here's a little guidance on the notes have started, so I'm recording right now. Here's a little guidance. If you don't see the image moving and there's a little bit of chitter chatter, you may want to wait till the image moves, like you can fast forward. Anyways, okay. So here was the whole point of what we just did. Isosceles triangles mean that these are equal. Means that these are equal. And what's a better word than equal in geometry? Congruent. Now, I don't like what I just did because those marks that I just made means what? So I should probably do this because it's on the same paper. Oh, you got carried away there. All right. This is shape A. Does anybody or shape B? Does anyone remember what this angle was? Was it about 60? It was. You got it at 60. What was this one? That was 60. Okay. Anybody remember what this one was? 81. Anybody remember what this was?
81. It was all 80.
Okay. How about this one?
That was 60.
It should be bigger than this one.
87.
87. What was this one then,
I
Ben?
guess, am I right?
I don't know.
It was 87.
What?
Ben, you're a dog.
Ben.
Ben.
Why is that for our group too? I guess 15.
So here is the $1 million observation. Here is the $1 million observation.
We get $1 million if we get this one? No.
You get $1 million worth of knowledge. So what do you notice is guys, don't stop. What do you notice about the angles?
They grow. They have nothing.
The angles are congruent. Now, are all the angles congruent?
No.
Okay. Okay. So if you have an isosceles triangle, okay, then the base angles are congruent. That's what this whole section is about. Everything's about knowing that if these two sides are the same, then their base are the same. The only thing that I could do to make it tricky is maybe turn it on its side. Okay? And you got to go, oh, it's not these two now. It's going to be these two. Okay? So let's look at your notes. So basically this first thing just says that. Okay? Says that if these are, and go ahead and mark this a little bit clearer. Those are congruent, then these angles are congruent. I don't know why they chose to do it on two drawings. I think it makes more sense to do it on one. Okay? But if your sides are the same on the triangle, then the base angles are congruent. And they go, then the sides opposite those angles are congruent. Okay? Other textbooks would call them the base angles. I guess that confused people when the triangles turn, but okay. So then right here, they say we're trying to find what x is. Well, first of all, tell me what we know in A, this shape here.
That all of the angles combined equal 180.
Okay, so all three, 1, 2, so 1, 2, 3 equal 180. We have a blank there though, Brody.
It's 28 because the I forget what it's called, this is the same.
Okay, it's a nice isosceles triangle, so the base angles are the same. So if that's 28, then that's 28. So now I can write my equation. 5x plus 9 plus 28 plus 28 equals 180. Okay. That's a degree symbol. I'm sorry, it's blurry. Okay, so 5x equals what? 180 minus 28 minus 28 minus 9.
That's 115.
115. Divide by 5. 23. And if we wanted to, if it had asked it, we could then actually find out what this angle is. Okay, by plugging that back in, or 180 minus 28 minus 28. Okay. So basically, they're just going to use this same information over and over again. So this B here, we know that this chunk is equal to that chunk by that theorem. Negative 4x plus 9 equals 8x minus 3. So 12 equals 12x. Not too quick of a step there for you. Miss McCarthy, would she fuss over what I just did?
I disagree with your answer. Not 12x, it'd be 4x. It's a negative 4x, so you would subtract that.
No, you would add it.
You would add it to both sides.
That would still make a negative 4x.
Add 4x.
So I got to get rid of that negative 4x by adding 4x.
Then you add 4x.
Oh, never mind. I'm slow. My bad.
And from that, I could find out all the angles, but it doesn't ask that question. Easy peasy strawberry lemonade.
Yes.
Okay, here they're actually going to do the two parts. We're going to say find x and then find the lengths of all three. Okay, from the rule, we know what can we set up.
8x plus 4x plus 5.
Okay, so this part is equal to that part. Okay, other geometry students would think, well, I got to use this, but no, not yet. So then we have 4x equals 6. X equals 1.5. Okay, so there's part A. And then part B says find the lengths of all three sides. So I'm going to put 8x, so 8 times 1.5 minus 1 equals 12. 11, 12 minus 11. Okay. Do I need to do this one?
No.
Why don't I have to do that?
It's 11.
Should also be 11. Okay. It wouldn't be bad to just check it. Okay. But I don't know. I'm feeling pretty confident. I'm just going to move on. So I have 11, and then 2 times 1.5 plus.
It's 14.
14. You're arguing a number.
Okay, so this is how I would like you to answer these type of questions. It'd be 11, 11, 14. Okay, and the computer's kind of picky about how you answer things. That's probably exactly how they want you to answer it. The smaller one comes first, and then from there. Geometry is often just, here's a rule, now use it over and over and over again. Okay. How many of you noticed that rule as you were describing the shapes? Okay.
Yeah, it's terrible. I hate how you have to just do one thing over and
I just
over.
did-
In
I just-
algebra, you get thrown different things.
Yeah.
I just stopped giving them angles. I just said, cut it in half, go with the length up. Yeah.
Oh, okay. So Brody
And
and us.
Same thing.
Okay. So he said cut it in half. and then go straight up. What is cutting something in half and going straight up called?
Perpendicular bisector.
A perpendicular bisector. So looking at the other side, Brody basically used theorem 4.2 without knowing that it was a theorem. So theorem 4.2, just so you know, why do you think this theorem is called theorem 4.2? Where do you think the 4.2 comes from?
I don't know.
2.2.
Okay, so if it was a different textbook and this was section 3 of chapter 5, it'd be called theorem.
3.5.
Yeah, okay. So that name of the theorem is completely based on the textbook, but we should call it the Brody and us theorem.
No,
Okay.
put our names in it too.
I did, us.
Bernie and Andrew and
It should be called the Brody plus us. He said cut it in half, and then you know that these, and he figured this length, and then that basically describes the other one. Okay, so basically we still know that this and this are congruent. We know that this angle should be the same as this angle. Okay, but also, and then it cuts it in half, so this is going to be the same as this, and this is 90 degrees. Okay. So if we take a isosceles triangle and cut it in half at 90 degrees, also it doesn't show it, it's right here. Sorry, it's not very clear, but that this angle is congruent to that angle. So looking at this next question, so it tells us that that's 37 degrees. Okay, without knowing anything else, what else can I find?
37 degrees.
It's a T that QR asked.
That's a T? No, it's a 37.
That QR asked me.
Oh my gosh.
Where it says 37.
37 where?
Where does it say 37?
Oh my God.
Oh my God, Mark.
Angle QPS.
That's 31, it's not 37.
SBQ 37.
Yeah, I want to make sure that it's a 31
We're good at T.
or 37.
The top line.
That looks like
You
a
already
seven.
officially placed yourself.
So this angle right here, 31,
That looks like 37.
it does look like a 37, but it's a 31. So this angle over here is 31. Let's see, it wants RSQ. It wants RSQ. So this is the angle we're looking for.
Well, that's a 90.
Okay, this is 90.
And then 121 minus 180 is.
Make the whole equation for me, Brody.
180
180,
equals 31 plus 90
31 plus 90
plus S.
plus the reason, why can't I call this angle S?
Because that's the point.
What? I can name this angle R, but I can't name this S because there's two angles at S. That's why I think I like you guys calling it X, okay? Because you know that that's what you're talking about, okay? So you're just creating that variable. So 180, 59 equals X. Again, Miss McCarthy I can hear her yelling from her room. And you know what we say? Okay. So just so we're clear, if this was a test and I was grading this, I would not give you credit because you need to say that the measure of angle RSQ equals 59 degrees. Okay. Then they want us to figure out the length of PR. Oh, that's easy.
It just said what is PR? How do you have length?
So when go ahead.
Because there's a perpendicular bisector, so it's going to be the same on both sides.
Yeah.
4 plus 4 is 8.
Yeah.
Okay, but Brody's question was, how do I know that when I just say PR, it means length?
There's nothing on top of it.
Okay, right. When there's nothing, if I did PR like this, then I'm talking about a segment. But when I say PR, oh goodness, I can't write. PR, that just means what's the length from P to R. So the length from P to R is 8. I thought it would be fun if they also had given us, we could use Pythagorean theorem and find the other two sides. Or we could use, do we know SOHCAHTOA in here yet?
Yes, we do.
Yeah.
So we could, using SOHCAHTOA, we could find this length and this length. Yeah, we'll get there.
Oh, yeah.
Oh, that's sticky.
Sine, cosine.
Oh, yeah.
Oh, yeah. How do I remember? I had so much trouble with SOHCAHTOA.
Maddie doesn't forget. I didn't forget. Maddie holds grudges. So she-
I'm sorry this printout is so awful, but
Come on, give her.
so here we have a isolateral triangle.
Isolateral.
Why am I saying that wrong?
Equilateral? Isolateral?
Where are you getting isolateral?
What was that?
Isosceles. What is wrong with me? Here we have an isolateral triangle. What is an isolateral triangle?
I honestly did not know that.
Isosceles. True.
No, it's non-existent.
It's an isosceles triangle.
Isosceles equal.
It is.
True angle.
If frenemy is a word, isolateral can be a word too.
Yeah.
Isosceles.
Does that mean an equilateral isosceles? Does that mean an equilateral isosceles triangle?
No.
That's what I'm messing up.
It is a word now. It is a word now.
Yes, Mr. McConnell made it into a word. What I say goes. I'm teacher. I'm in charge. I have many badges, even though I bought them and they're made of plastic.
Get arrested for fraud.
All right, so an isosceles triangle, an equilateral triangle follows that rule. So these are the congruent sides, then their bases are the same. Okay, and if I turn it, this is how I describe it to most students. If I turn it, now these are the isosceles, so these bases are the same. So really, we should know that if it's an equilateral triangle, then what's true about their angles? We also know that equilateral triangles, that their angles equal what? 60. So the measure of angle A equals the measure of angle B, which equals the measure of angle C, which equals 60 degrees. Okay. So they basically want to throw in here the fact that it follows the rule of isosceles triangle that the two sides make the base angles congruent. Yes. Okay. So looking at this next figure, it says that the measure of angle CBD is 130 degrees. Okay. What is BAD? Okay.
Bad.
CBA. So I wish this was a little bigger, but this angle right here is 60 degrees. How does she know that? It's equilateral. Okay, so because this, and I know that it's hard to kind of see, but this is an equilateral, so all those angles are 60. So then that makes this angle right here what? Makes that 70.
Yeah.
Oh, yeah.
And we're looking for angle BAD.
Divide 1 by 2.
Wait, that's.
Because since it's an isosceles triangle, the other two are the same, so we divide by 2.
Okay, we know that the triangle, that this angle, let's call this X. If that's X, then what's the measure of this one?
55.
You're answering the question. If this is X, then what is this one?
Or as X.
It's also X, right? Because we know that they're the same. So X plus X, or 2X, plus 70 equals 180. Okay.
Wait, isn't angle A, angle BAE 60?
What?
55?
Yes. Oh, you're good.
Okay, so I know the drawing's really hard to see. I think that Mark is thinking that this triangle here is equilateral, but it's not. This is not an equilateral triangle. Okay. So if I were to redraw this so it was clearer. This is the worst notes, I think, as far as being clear. I don't know why, but we have this shape here, which is equilateral, Mark.
Yes.
Okay, and then we have this one, which is just isosceles.
Yes.
Okay.
Wow.
So this is 60.
Shouldn't that one be 60 also because those are equal?
This is 60. This is 60.
And then that one that's
That'd be 180 degrees though. It's
That's 70.
Why is it
Because
70?
in the thing it says CBD.
That doesn't make sense though.
Yes, it
Yes,
does.
it does.
If it's equal, look, see the
Isosceles
Mark,
line.
130 minus 60.
If the bottom line is longer, then the top angle would be wider.
Wait. Pause. 1 second. Let Mark ask a question instead of just trying to tell him what he doesn't see.
It's 60.
Why?
Because- So this is 62, right? Because
No.
What's
line is
60?
there. See, it's equal too.
Uh-huh.
Yeah.
That's a segment, not an angle.
So you're wanting to say that because this side here has a degree that's 60, then this has to be 60.
No,
No.
man, never mind. Just.
No, I like the challenge of trying to understand.
I think he's saying because the two, he's saying because the two segments are congruent, that
The
angle in
angles,
between should be 60.
Just like.
But I want Mark, that means all three angles have to be, all three segments have to be.
So here's our isosceles triangle flipped around that we're kind of working with, right? That's the isosceles one. And that means that this angle here is got to be the same as this angle here.
Yes.
Do you agree that this is 70 degrees?
Now I do.
Okay. So if that's 70 degrees, Brody pointed out that triangles equal 180. If you subtract the 70, you're left with 110. And these two angles have to split the 110 equally. So that's how we got 55.
Okay, thank you.
You're welcome. Thanks for coming. All right, the last one here. Sure.
Okay, so for A, since the triangle MPN is equilateral, so the angle MMP is 60.
Okay, so this angle right here is 60.
And since it's a line, it's 180 degrees.
Okay.
Yeah, so the line NP jets off. PN,
Okay, so he's telling me what this angle is.
that is 120.
120.
Because there's a horizontal line, and horizontal line has an angle of.
So the answer to A is 120.
Okay, hold on 1 second. I'm going to try to draw this a little better.
Do you know that in Mark 70?
Oh.
Okay, so he said that this was 60. Straight lines add up to 180, so this is 120.
That's the
That's the answer
answer.
to A, because so the measure of angle P and O equals 120. Okay.
And then for B, take 180, subtract 120,
Okay.
and then that would be 60. And then you divide that by 2.
Okay.
And then it would be 30 for a measure of angle NP.
Okay, so this angle is congruent to this angle. There's 180 is the triangle, so subtract 120. So we have 60 left between the two of these, and they have to be the same. So this would have to be 30, and this would have to be 30. So the measure of angle NOP equals 30 degrees. Yeah.
When you're
We
doing
did this.
perpendicular bisectors, everything that's the same
We did
on
this.
both sides. And so that one actually
Say it one more time.
March.
This here.
March. I don't either.
Yeah, when
I
it
was
goes
I had kind of like a cold.
because it's directly down the middle.
Okay. So, hey guys, here's the $1 million question she's asking.
Another one.
$2 million for knowledge.
What is that in relation to that?
The same.
What is the green line?
Half of it. Green is half of the purple.
So the words that we used earlier, transversal would be parallel lines. The words we had before were perpendicular bisector. This is not a perpendicular bisector. This is just a bisector. So in order to make those angles the same, it has to be a perpendicular bisector. Because if one of the angles is 60 degree, perpendicular bisector has to have what degree angles? 90. So if one of them 60, then it's not a perpendicular bisector. Okay. That's right. You guys are knowledge millionaires.
Why would you not?
I should have 60.
Knowledge
Knowledge.
millionaire. I went and saw a movie.
I was regular.
We're knowledge millionaires.
Knowledge millionaires.
I don't know.
You're right.